you.
Okay, a parabola. Okay, we know what a parabola looks like. Okay, we've studied parabolas back in chapter 2. We're going to define parabolas a little bit differently in this section than we did back in section 2. So, a parabola is the set of all points which are equidistant from a fixed point. That fixed point is called the focus, and a fixed line. And that fixed line is called the directrix. Okay. I'll try to make the lines bigger next time. Sorry. Okay, so, to get a visual of what this means, okay, I've got a little, not there. Let's see if we can reload that so it looks a little bit nicer. It's just supposed to show one set of lines at a time, showing that those distances are the same. There we go. Okay, so as I move this point, okay, we're creating a parabola, okay, based on lines or distances that are exactly the same from my focus and from my directrix. Okay, this is what creates a parabola. Right, those distances are the same. Okay. So, the standard equation for a parabola with a vertex at 0, 0 and a focus at either A0 or 0A is going to be x squared equals, now this could be plus or minus. This does not mean it's both plus and minus. This just means it could be positive or negative for a y. Or we could have y squared equals plus or minus 4ax. Okay, worked with more often. So in this format, if x is squared and this is in the right side of the equation is positive, my parabola is going to open up. Okay? If x is squared and negative, my parabola is going to open down. If y is the variable that's squared, and my parabola, or in the right side of the equation is positive, my parabola is going to open to the right. Okay, it'll be a sideways parabola like this. If y is the variable that's squared, and the right side of the equation is negative, my parabola is going to open to the left. Okay. So, in these equations, the value of a is pretty important. Right? The value of a tells us a couple of things. It tells us the distance from the vertex to the focus. And it also tells us the distance from the vertex to the directrix. Okay. Therefore, 2a is the distance from the focus to the... So a visual, okay, what that is saying. Okay, if I have my parabola and my focus is right here, and then my directrix is down here. Okay, so here's my directrix, my focus. The distance from the vertex to the focus, that distance is A. Then we can say the same thing here. The distance from the vertex to the directrix is also a distance of A. And so that's what this part is actually saying. All right. Questions so far? All right, so the examples of graphs here, okay, is just, like I said, our parabolas could open up, down, left, or right. Okay, so we could have a parabola opening down over here, right? And I mean, if we want to draw in our focus and directrix, we can do that. And again, that distance from the focus to the vertex is A, and the distance from the vertex to the directrix is also A. Right? So this distance here is A, this distance here is A. We can also have our parabolas opening left or right. Okay, so I could have something that looks like this. My focus here, and my directrix over here. Okay, and again, I guess that's a little bit off. Distances aren't quite the same in my picture, but those two distances, right, from the focus to the vertex, and then the vertex to the directrix, should be exactly the same. Right. We're going to skip the part in the book here for now. So let's actually try a couple of these here.
So would the one on the right not be a function then?
That's, yeah, absolutely. So if we're thinking about our definition of a function, where it would have to pass the vertical line test, that isn't technically a function. You're right, yeah. So, if I'm given these equations, okay, we want to graph our parabola with the correct focus, vertex, and directrix. Okay? So, we said up at the top that for all of these examples on the front, okay, it says the vertex is at 0, 0. Okay? But if we think about our form, we said x squared equals negative 4ay. Okay? So if my coefficient here is negative 12, how would I figure out what a is? Yeah, right? We're essentially setting negative 12 equal to negative 4, or negative 4a. So divide by negative 4. And we would get that a is 3. Okay, so A is the distance from the vertex to the directrix and the vertex to the focus. So now, we set our vertexes at 0, 0. Is this parabola going to open up, down, left, or right? How do we know it's down? Because x is squared, and the right side is negative. Okay, so x being squared tells me it's up or down. And then the right side of the equation being negative tells me it's going to be down. So, my parabola is going to open down. Okay. Where's my focus going to be? At 0, negative 3. Okay. My focus is going to be inside of the parabola, and it's a distance of 3 away from the vertex. Where's my directrix?
Would just be 0, 3.
So, remember the directrix is an entire line, so it'll go through the point 0, 3. But it will be the line y equals 3. Okay, so this is my directrix, y equals 3. Okay, and then the vertex is at 0, 0. Okay with something like that? Okay. See if you guys can try B here. Okay, so we know the vertex is at 0, 0 for these. Then you need to figure out whether it's going to open up, down, left, or right. Then figure out the value of A to find where the focus and the directrix will be.
Or the other. Like square. Like
How like it becomes negative just in the distance.
So this technically we should all, because we need to choose the appropriate form, right? Like if this was negative, I said, well, that corresponds to the x squared equals negative 4a, so we would be setting a negative equal to a negative. This was positive, I chose a positive version of our standard form. Okay, so a is a distance, so we should always get a positive value for a. But yeah, I guess if you mess up and throw a negative sign in there, you just ignore the negative sign. So I think we should get that a is 3/2, right? My parabola is going to open to the right because y is the variable that's squared. My equation is positive. So my focus will be at 3/2, 0. My directrix will be the vertical line, x equals negative 3/2. Questions so far? So let's just take a look then at parabolas where the vertex isn't 0, 0. Okay, all we're going to do is throw in h and k. So again, we can have two different versions depending on which variable is being squared. So I could have x minus h squared equals negative 4a times y minus k. Alright, I guess not negative 4a, plus or minus 4a. And again, that's not both plus and minus, it's just plus or minus. It could be positive or negative. And then we could have our y variable squared minus 4a times x minus h. So the only thing that could be a little bit tricky when we're looking at these two forms of the equation is picking out the vertex. Okay. Normally, especially for a circle, we always write it as x first, then y, right? X minus h squared plus y minus k squared equals r squared. Here, we always just put whatever variable is being squared on the left side of the equation. So if x is being squared, the vertex would be hk, right? We would read it from left to right. But if y is the variable that's being squared, we just have to be careful that this is the x-coordinate of the vertex, this is the y-coordinate of the vertex. Okay, it's just whichever, the x-coordinate is the one with the x, the y-coordinate is the one with the y, but you just have to be careful that we're not just reading it left to right. Okay? So, I mean, this is the same idea as on the front. We're just introducing an h and a k into this formula. Right? So, on here, okay, on these problems, we're given some different pieces of information. Okay, we're given either the focus and the vertex, or the focus and the directrix, or the vertex and the directrix, and we need to write an equation in this form, given those pieces of information. Okay, so to write the equation of a parabola, I need two things basically. I need the vertex and I need the value of a. Well, if I'm given the vertex, that makes this pretty straightforward. Right? It always helps to have a picture. So I'm I'm always going to sketch out a little picture based on what we have. So I know the vertex is at 0, 0, and I know the focus is over here at negative 8, 0. So 1, 2, 3, 4, 5, 6, 7, 8. Focus, vertex. Just based on that information, which way is my parabola going to open? Up, down, left, or right? To the left. Okay? Actually, if the focus is that far out, it's going to open pretty wide. Okay? So, right off the bat, which of my variables is being squared? X or Y?
Y.
Y. And then is the right side of the equation positive or negative? Negative. So right off the bat, I have almost all the information I need. Right? I have my vertex is at 0, 0. So we don't have to write this out, if we know that it's 0. But I'm going to go ahead and write it out as 0 for the x, 0 for h, 0 for k for now. So x minus 0 squared equals. Did I already ask whether the right side would be positive or negative?
Yeah.
Yeah. So we said it would be negative. So negative 4 times a. We still don't know what a is, but then I know that the k value will be 0, right? How do I figure out what a is?
Count the distance from the focus to the vertex.
Yeah, right? It's just the distance from the focus to the vertex. That distance is 8. Should I put a negative 8 in here, or should I put a positive 8?
Isn't it just the absolute value?
Wait, say that again? Oh yeah, I did mess that up, didn't I? I asked that which one should be squared, and then I wrote the wrong one. Thank you. So, yes, this value of A, will always be positive, right? We accounted for opening to the left right here, right? We already said that this is going to be negative. So the value that we put in for A is just the distance. The distance is always positive, right? So, to simplify this a little bit, right, we can just write this as y squared equals negative 32 times x. Questions? You guys feel like you can try a couple, or do we want to do another one together? Another one together? Okay. So we take a look at B. We're given the focus and the directrix. So first thing I'm going to do is sketch a little picture. Let's see, the focus is at 0, 4. And the directrix is down here at y equals negative 2. So I have to find the vertex this time. If I know the focus and the directrix, how do I find the vertex?
Just find the half point.
Yeah, we want to find the point that's exactly halfway in between those two, right? So the distance between the focus and the directrix is 6. So I just want to go a distance of 3 from either of them, right? I'll end up in the same spot, right here at 0, negative 1. So my vertex is at 0, negative 1. So is my parabola going to open up, down, left, or right?
Up.
Is what? Oh, yeah. Thank you. Yeah, no. So is it going to open up, down, left, or right?
Up.
Up, right? So that automatically tells us that x is the variable that will be squared, and the right side of my equation is going to be positive. So we will have x minus 0 squared equals positive 4. Now what's my value of a?
3.
3, right? A is the distance from the vertex to the focus, or from the vertex to the directrix. So that'll be 3 times y minus 1. So again, we can simplify this a little bit. This would just be x squared equals. Now, I'm not going to distribute the 12 through the parentheses on the right side. Okay, we're just going to leave it in this form so that we can see the vertex from our equation. Okay, this is the what's called the standard form of a parabola. Okay. Feel okay?
So the value was like the value in front of the right side of the equation was negative last time, and now it's positive.
Yeah. So we said, I guess we could have rewritten it here, but on the very top we said if x is squared and the parabola in the right side is positive, it opens up. So here we have x squared, and it's positive, meaning it's opening up. If x is squared and it's negative, it's opening down. So that we kind of went backwards here. We said, well, we know it opens up, therefore the right side is going to be positive. Here we said, well, we know it opens to the left, therefore the right side is going to be negative. Other questions? All right, you guys try C then. Okay, we're given the vertex and the directrix this time. Did we get something like this? Okay, so we know the vertex is at 1, 1. The directrix is at y equals 2. So that tells me automatically the parabola is going to open down. I know that my a value, the distance from the directrix to the vertex, is 1. So this is what we should end up with. Okay? Questions? Okay, so the next part then is picking these pieces of information out given an equation. Okay, so here we have equations of 4 different parabolas, and from those we want to find the vertex, focus, and directors. All right, so scroll a little bit. So the vertex should be pretty easy to find right off the bat. What would the vertex of this first one be?
Oh,
Right.
crap.
You got tricked already.
Yeah.
Okay, the x is on the right side here. So the vertex is going to be the point 3, -2. Well, now, how do I find where the focus and the directrix is?
The A value.
So we need the A value. What's the A value for this one?
2.
2. Okay, because this is 4A, right? So if 4A equals 8, that means that A is going to be 2. Now, is this parabola going to open up, down, left, or right?
Right.
It's going to open to the right because y is squared. The right side of the equation is positive. So even for the ones that don't ask you to graph it, I still think sketching out a graph is going to make it a lot easier. So I know the vertex is at the point 3, -2. I know it opens to the right. And I know my A value is 2. So how do I find, from that, how do I find the focus and the directrix?
You just move 2 along to the X.
Exactly. I'm going to go 2 to the right to find focus. So that will be the point 5, -2. And then I'll go 2 to the left to get my directrix. So that'll be the line x equals 1. So focus 5, -2, and directrix x equals 1. Right? I mean, maybe you can do it without the picture, but for me, I think the picture makes it a lot easier. Right? Just quickly sketching out. If I know it opens up, down, left, or right, that lets me see where the focus and the directrix are going to be much quicker. Okay. Questions? All right, let's take a minute or two and have you guys try a couple of these. Okay, so go ahead and try B and C here, and if you get there, go ahead and try D. I'll cut you off in a couple of minutes because we're running a little bit short on time. So if we don't get to all 3 of those, that's okay. Say that again. So on this one, the parabola opens up. Right? So if my vertex is at 3, -1, then to find the focus, I would have to go up 1. So if I'm at 3, -1, and I go up 1, that'll be the point 3, 0. On which one? Oh, did I? Oh, yeah, it is. Thank you. I'm trying to go too fast. 1. That means that this is going to open up since x is squared, the right side is positive, and then my a value will just be 1 if I set 4a equal. So from my vertex, I'll go up 1 to get to the focus, and down 1 to get to the directrix. For C, my vertex, -3, +2. Then my a value, if I set -12 equal to -4a, my a value would be 3. So I will go 3 to the left to get to my focus, because my parabola is going to open to the left, and 3 to the right to get to my directrix. Questions? All right. Let's try one last problem here. So on first one on the back here, example 4, it just asks us to complete the square to find the vertex of this problem. Right? So the only variable that is squared is y. So that tells me I want to get all my x's on the right side of the equation and all my y's on the left side. Right? So the first thing I'm going to do is move the x and the 7 over to the right side. So I'm going to have -2y squared plus 8y equals -x plus 7. So now, to complete the square, we want to have our coefficient of the squared term be a +1. The easiest way to do that is just going to be to divide the left side of the equation, divide both sides of the equation by -2. Right? So if I divide both sides of the equation by -2, I'm going to have y squared minus 4y equals, now I could write both of these over -2, or I could instead write it as -1/2 times x plus 7, like that, times, yeah, forgot the negative sign in there. So now, to complete the square, just like we did with the circles yesterday, I need to add a value right here. What value do I need to add to both sides of the equation? y4. b over 2 squared. So -4 divided by 2 is -2. -2 squared is 4. So I'm adding 4 to both sides of the equation. So now, how does this side factor?
Wouldn't it just be y minus 2 squared?
Y minus 2 squared equals. So now I've got to clean up this side of the equation some. Okay? To do that, okay, I want this to be a positive x. Right? So to do that, I could go ahead and distribute this -1/2 through and then clean this up a little bit. I'm going to go ahead and do that. There's a couple of different ways that we could go through this process. Okay, but if this is 1/2 x, this will be -7/2 plus 4. So now, if I clean up this side, I've got 1/2 x. -7/2 plus 4 would be, yep, oops, just 1/2. So now on this side, to make x positive, I can factor a 1/2 out and make this 1/2 x plus 1. Okay, the goal is to write this so that we have a positive 1x on the inside of the parentheses. Okay. Questions? All right, I will make